Haven't done science in a while because I got two roadblocks. And my go-to excuse is that I don't have the leading edge research papers. And laboratory works. This includes electrical engineering. This includes biology. But AI possibly can give me as much resources as I require, equivalent to that of the leading laboratories. Possibly, because I can simply fucking ask it what is done in those leading laboratories, which experiments, which results, which data, which techniques, which compounds, which experiments, which work is actually being. I could probably ask AI that specific question. Yes, you gotta really dig it. But hopefully AI has improved now, where with one prompt it will spit out complete detail. It does it about 30% of the time. 30% of the time I prompt AI and it gives me very technical, detailed stuff. 70% of the time still it's mumbo jumbo and you gotta keep digging around. That being said, my roadblock is probably because the work I've been doing. So I focus on 3 areas in science: electrical engineering, cancer, neurological disorders. Simple. Electrical engineering, high power, I'd say. What am I trying to do with electrical engineering? Quantum stuff. Quantum electromagnetics. So electromagnetics, generation, power, solar, photons, quantum, transformers, low power, high power, transmission, generation, everything basically on low power and high power with electromagnetics. And electromagnetics is the core concept of electricity. What is electricity? It's an electromagnetic current. So it's a flow of electrons. And this flow of electrons has electromagnetic properties. And the mathematics behind electromagnetics is shared with all of electrical engineering. So it's basically electrical engineering. And that's one area. The other area, cancer. There are 4 methods to combat cancer other than screening. So screening and diagnosis, there can be many improvements there. Screening and diagnosis, the techniques, the accuracy, sometimes you don't want to screen because it's unnecessary. Like, if you screen for 10 different, like 20 cancers in your body, you're gonna get a positive somewhere. It could be a false positive, it could be a real positive, but a lot of cancers, or some cancers in your body, are resolved on their own. They don't grow past the very minimal stage. So if you screen for cancer at a little bit more advanced stage, then it becomes a concern. But if you screen and like a blood test or something, something like that, and you get particles or whatever, and then you got to do more tests and more trauma and everything, and it is false positives, and so sometimes screening is not always the best. So we need accurate diagnosis, but even more important than the diagnosis is the treatment. And there's 4 areas, because cancer is generally a tumor unless it's in the blood. It's cancerous cells that grow, replicate, and sick, diseased, aggressive cells. And there's often tumors involved. So first method is surgery to remove the tumors, which also involves removing some part of the body that was attached to that tumor. So to make sure the tumor's completely gone. So that's surgery. Then you have radiation, which is electromagnetic waves, high frequency waves like X-rays or radiation, some sort of rays. To once again kill tumors. Then a step above surgery and radiation is chemotherapy to kill cancerous and healthy cells. So that kills all cells. So like that's the foundation of your body. The foundation of your body is that maybe that could be a next area of research. Is cancer part of the body? Because it's instructed by DNA. This is technical now. Like, do we attack the DNA? Do we attack the proteins that are carrying out the DNA's commands? That's technical. That's my next area. But so chemotherapy attacks all cells from replicating, which is healthy and cancerous. So it has side effects. And then the new areas are targeted therapy and immunotherapy. So immunotherapy is getting the body's immune system to mark T cells and activate the lysosomes or whatever attacks them. So that's the immune system. However, if you over engage the immune system, you will hurt your own body. You will get inflammation and attacking your own body. So some immune system, like, you want to support it, but if you get too like, you can even get serious diseases. There are in fact serious other diseases that are caused by overactive immune systems. And targeted therapy is the area I have been working on. Everything. Targeted therapy targets the function of the cells. So the DNA is glitchy, and the cells carry out those commands of the glitchy DNA and start creating proteins, which are receptors on membranes and commands and everything like that. So they have these, the DNA is the instructions, and the proteins, the building blocks, are the executors. So targeted therapy works to block those proteins, block the DNA. And it's got to be different because every cancer is a little bit different. So different cancerous cells are different from other cancerous cells. So you got to modify these proteins, modify those proteins, modify these proteins, enzymes which go with proteins. So it's all about enzymes and proteins and DNA, which is how the cells function. That's targeted therapy. Sometimes it's effective, sometimes it's not, because cancer is very different. If the cancer is very diverse, it's very complex to use targeted therapy. Targeted therapy works best when the cancer is uniform. So that's electroengineering, electromagnetics, cancer treatments and targeted therapy, and neurological conditions. You got your brain, which is starts where the command starts, and a neurological signal is sent from neural cells. They're cells, but they're neurons, and they carry voltages. And so when one cell gets activated, it creates a voltage which activates the next cell. However, it's not only the voltage, you also need a neurotransmitter, which is a chemical. So the electrical signal sends chemicals to the end of one cell, to the stems, and then these neurotransmitters have to fire and to the next connecting cell. And then that happens all the way down the chain. And that's motor function. So a lot of these neurological diseases are either brain function or motor function, because, or sensation, nerve damage as well, pain and stuff like that. Because the nervous system starts from the brain and then goes throughout the entire body. It's the largest organ in your body. All your nerves would connect around the earth 9 times the circumference of the earth, something like that, or go to the moon and back. All your nervous system. And the electrical signals have to go from the brain throughout the entire nervous system. That includes, if there's a break, the signal has to fire down the entire chain, and neurotransmitters within the brain have to connect. So if signals don't work, you can get motor diseases. If neurons themselves, the cells themselves start degrading, there's diseases that cause them to degrade. And then the entire system shuts down. Your organs start, which are connected to commands from the brain. Your biological organs will start to fail, and speech and everything starts to fail until death. That's the neurological chain from the brain to the body. And within the brain, if the transmitters themselves are not properly balanced and working, then you get mental disorders and conditions. And if any signals start degrading within the brain, then you get things like dementia and Alzheimer's and stuff like that. And the treatment for cancer and the nervous system is like healthy eating, healthy working out, sleeping, stress, no smoking, no alcohol, stuff like that. That's the only prevention there is. There's not many treatments. That's why I'm doing work in these areas. There's not many treatments for that are really curing the problem for cancer and nervous system. However, we know the causes. We know the disease itself. We just don't have a cure for it. Like for the nervous system, the reason neurons die and signals get broken is because, like I said, the neurotransmitters, the electrical signals, and the cells themselves can have faulty proteins and DNA yet again. So misfolded proteins and oxidative stress. So you heard of antioxidants. Those, now, sometimes too much is the problem. Not from the food or whatever, but in the body, the way they're processed. It's called antioxidative stress. So these oxidants are overactive, and that's causing problems in the cells. And the other problem is the misfolded proteins. So that causes the neurons to be faulty, and they're trying to develop drugs to stop these folding proteins and stop antioxidant stress. And the way the entire disease progresses is it goes from misfolded proteins or antioxidant stress, misfolded proteins, inflammation, and it's a cycle that keeps building on itself, feedback. So oxidative stress, misfolded proteins, inflammation, and they keep leading to each other. And what happens is the neurons degenerate until death, and that's why there's no cures for them. All we can do is slow the progression of the disease. So that's where my work has been going in. And what I have done so far in terms of electrical engineering, cancer, and neurological conditions is provide a framework of the big picture. That's what I did. I outlined all the diseases, all the functions of the body and the biology in technical detail, and the faults, where the faults are within the biological processes which lead to the diseases. And I outlined some solutions, some branches of research that are currently being done, like I said, for the cancer, chemo, radiation, surgery, targeted therapy, immunotherapy, and as well as any drugs or vaccines that are also being used to help with treatments. So I outlined the biological functions and the mechanism of the diseases. Same for electrical engineering. I outlined the natural phenomenon of the physics behind electromagnetics and some extra areas. However, that's as far as I got. So I outlined everything in biology and electromagnetics, but I haven't broken through any solution because I don't have a lab, I don't have experiments, I don't have whatever, but I don't have any hypothesized groundbreaking solutions. I set up frameworks, and maybe going forward I have to just research into the frameworks I developed, because I'm always digging for AI, like digging for more topics. Maybe I have enough right now and enough knowledge, and I just need to manually come up with solutions and start putting pieces together for biology and electrical engineering. Anything else I worked on in science, those are my favorite areas. The last medical area, that big medical area, is illnesses that are viruses. So something that can cure all viruses, like what does every single virus have in common? What functional structure does every virus have in common? So we can weaken at least every single virus with the same vaccine. That would be a breakthrough. So that's as the fourth area, but mainly first the neurological system, cancer, electrical engineering, and then viruses. And I found out, like, there's vaccines, drugs, screening, tests, scans, nutrition, organs, hormones, enzymes, receptors on membranes, process ATP, processing energy from glucose, fats and proteins, and macrobiology. So focus on that part. And electrical engineering, research Maxwell's books, Faraday's books, Einstein's work, Nikola Tesla's work, my university schoolwork. So just basically I'm putting together all the science and physics that I'm aware of, trying to put pieces together and come up with new theories for improvements into this scientific field. Like I said, I started this video off saying I came to a roadblock, and I believed it was AI that was causing the roadblock, but maybe I am gotta rely less on AI right now and dig more into the content I have. Like, that's how I initially started doing scientific research. Before ChatGPT existed, I wrote 30 pages on scientific research in 2024, and that was before ChatGPT. So, and maybe I gotta go back to doing that again, and just fact checking my theories with AI. That would be a fun time, because I got so much knowledge for science, and my excuse has always been I don't have the research papers, I don't have the laboratory, the data, the resources. But maybe you just gotta work around that. All right. Bye.